Assalamu alaikum. This is Zarin Tasnim Trami. My ID is 18101589. Now here first we created a new world and added a textured background, then added light to it. Next we added a rectangular floor arena. We did all that by clicking on Add Node, then clicking Protonode. We changed the size of the rectangle arena and made it big. Then we build a robot that will be described by our another groupmate. In the robot, we used distance sensor. We mainly used three distance sensors and their type is infrared. We named them as right, left, mid, respectively. Then we are to input lines for our track. To do that, we used Autodesk Tinkercad and created a new design. We used Scribble and drew a line and made the height very low and gave a color to the track and exported. Then we imported the 3D model. Then we changed some measurements of that track to make it fit on our rectangle arena. Then we made our robot aligned to the track. This is all about environment creation and track creation. Now Nafia will continue.
Hello, I'm Nafia Binti Amin. My ID is 1810142. I'm going to be talking about the building of the robot. First, we determine the shape of its body, GPS, sensors, and the children part by adding shape components from the base node. Then in the geometry part, we chose the actual shape of them. We used box shape for body and distance sensor, cylindrical shape for the GPS. For wheels, we need rotational motor. So to enable the wheel rotation, we need hinge joint. For the wheels, first we add hinge joint. Under the hinge joint, turned endpoint into solid, and in the children part, added cylindrical shape. We also added hinge joint parameters, rotational motor to the hinge joint. From the geometry part, we fixed size, height, scaling, radius, translation, rotation value for each shape components of the robot. Gave them PBR appearance to determine visual properties, added color separately to all the parts, applied collision by using the respective shape in the bounding object, and applied physics as well. This way we added 4 wheels and 3 distance sensor and the GPS to the body. We checked the alignment of the sensor is covering the front, left and right part properly. And if we enable the GPS code, it will give us update about the global coordinate value.
Okay, this is Uber Firdaus Ishmael and my ID is 181014110. I'm going to be talking about the LFR Pro Python code, which is used to run our Python, our LFR robot. In this code, we can see that there is a left motor front, left motor, right motor front, left motor back, and right motor back. In this, the wheels are defined and each wheels are assigned with the name to get the wheels moving and to turn, help it turn right and left. In this, in the next part, we see that the set positions are solved here and the velocity are set here. And in the next part, we see the IR sensors, which are the right, mid, and left. We have 3 sensors, and the 3 sensors sense the paths it is going through, and if it is about to deviate from the LFR track. In the next part, we see that the while loop is going on, and we are getting the values, and we are using that values to calculate the speed we need to run at. In this print, we use the maximum speed here used. And in the if part, we see that there are multiple conditions for the sensors to sense if the robot is about to get off track and is about to deviate from the track. As a result, it helps to keep the LFR in the track, and the mid values calculation is helping the LFR to run smoothly in the track. Now we see the simulation here. And in this simulation, we can see that the robot is running smoothly and in the track. As a result, it doesn't deviate and it keeps the track and it keeps the movement to slow and speedy and steady. Thank you so much. This is all from our side, Group 4.